Okay, so today we are looking at the end of chapter 4, which is molarity and solutions, especially related with stoichiometry. So when we talk about molarity, molarity allows us to talk about the concentration of something, of a solution. So two solutions can contain the same compound but be quite different because the proportions of those compounds are different. So the idea of, so we can have two solutions of sugar water, but one can have a much higher molarity and thus much more of that compound present. And so and there are a variety of different ways that concentration is expressed. In chemistry, we use molarity and molality. In biology, parts per million, parts per billion, um, percent percent by weight are different ways that, like in biology and life sciences, concentration are typically expressed. But in chemistry, we use molarity, and molarity, as you already know, is moles of solute divided by the volume of solution in liters. And so, yeah. Now, when we go to make a solution, kind of the mechanism that we do is typically we weigh out a known amount of solute, usually so that we can get a certain number of moles of that compound when we dissolve it. And then we put that solute into a volumetric flask, and I have a variety. I have 100 milliliter, 250s, as well as 1,000 milliliter volumetric flasks. And the nice thing about volumetric flasks is that, so you add the solid into the flask, and then you add typically distilled water to that and dissolve the solid. And then you add enough liquid so that the meniscus up kind of that narrow neck is right even with this etched mark. And that etched mark is unique for every volumetric flask. And they're in the manufacturing process, they use a specific known amount of liquid that's been calibrated. They put it into the glassware, and then they mark the exact location where that, if for the liter volumetric flask, they then mark, after they've put in that liter of liquid, they mark the location on that piece of glassware, because technically every piece of glassware might have slight anomalies, or it might be glass might be slightly thicker in a location. And so for volumetric flasks, they are calibrated to exact volume amounts. So that's one way to get a solution, is take a solid, dissolve it, and get a specific concentration. Another way that is often used is by diluting down a solution. So let's say, and we're going to do some serial dilutions in class at some point, but the idea is you start out with a stock solution that's more concentrated, and then you add it to a volumetric flask, and you add more water to it and dilute it down and change the concentration to a lower. And when it comes to all of my acids, sulfuric, hydrochloric, let's see, what else do I have in stock? Hydrochloric, sulfuric, nitric, I don't have picric, but anyway, I have a variety of acids, and they all come as just concentrated solutions, and then I dilute them down for the concentrations that I need in laboratory. And this equation is kind of the easiest way to calculate new concentration from your stock solution. So the C standing for your concentrated solution, and your D standing for your diluted solution. So if you want to make, let's say you want to make a, let's say a 1 molar solution of hydrochloric acid, and we want to have 500 milliliters of it. So that would make my MD 1, because I want a 1 molar solution, and then my VD would be, I could either say 1 liter or I could say 1,000 milliliters. Either one will work for the calculation. And then let's say my stock solution for hydrochloric acid is always 12 molar. So I want to know what volume of that 12 molar stock solution I need to take so that I could then make this solution. So I would solve for VC. So I would move the MC over to the other side of the equation, and then solve for Vc. Just a basic algebra when manipulating this equation. All right, and then so when we use molarities, molarities are just another, they're just another proportion, another ratio, right? So when you think about it, it's moles per liter. So if you start out with 50 liters of solution, you're just going to set up your molarity so that moles is on the top and liters on the bottom, so we cancel our units and we move towards moles and whatever other thing we want to use it for. Or we reverse it if we want to know what volume of the compound or of the solution we need. Or anyway, so it's just another system of taking laboratory work, which is a measurement like concentration, molarity, and then manipulating it to do kind of, well, how much stuff is there, and that would be like working with moles. One other way that we explore concentration or calculate concentration is by doing titrations. We do a lot of titrations with acid-base chemistry, which is kind of modeled here in this example, but you can also do titrations just to detect or determine the concentration of just unknown solids or the presence of certain metals in water quality testing. So there's a variety of ways that you might approach it. And that's it. We'll see you on Monday. Or I won't see you on Monday, but